Lesson 8-3, Graphing Linear Relations, and in this lesson you learn to find solutions for the relations with two variables and to graph solutions. Okay, why is this important? Because graphing linear relations can help you determine how far away a thunderstorm is from you. Let's take a look at this example in science. Do you know that a cricket is nature's thermometer? You can use the equation T equals C plus 40 to find the temperature T. If you know the number of chirps C a cricket makes in 15 seconds. Okay, so look at this chart right here. Chirps in 15 seconds. If the cricket makes 21 chirps in 15 seconds, you simply substitute 21 to C, 21 plus 40. The temperature is around 61 degrees. Okay, 23 chirps in 15 seconds. Substitute 23 to C, the temperature around 63 degrees, and so on and so forth. If the cricket makes 47 chirps in 15 seconds, the temperature is around 87 degrees. Okay, so the chart shows the relationship between various number of chirps in 15 seconds and the temperature. Okay, so the domain, meaning our x-coordinate for this one, or our independent variable, would be 21, 23, 31, 50, and 47. Okay, and the relation would be the ordered pair of chirps in 15 seconds and the temperature. So for every 21 chirps, the temperature is 61 degrees. For every 23 chirps, the temperature is 63 degrees, and so on and so forth. And they all become ordered pairs all the way to 47 and 87, which means that for every 47 chirps in 15 seconds, temperature outside is 87 degrees. The relation can also be shown in the graph of scatter plot like the one shown at the right. So if you look at this one, looks like a scatter plot. And if you notice, okay, when we talk about scatter plots, okay, this seems to be a positive relationship because the dots seem to slant upward. Okay. So what do we know here? We recall that solving an equation, okay, means to replace the variable so that it results in a true sentence. The solutions, okay, let me undo that thing. The solutions of an equation with two variables are ordered pairs. Okay, so these are the solutions, okay, for your equation T equals C plus 40, where you have T and C, your first variable, and your second variable. Okay, and with this, okay, you know that 21 and 61 will make the equation true, and all the other ordered pairs will make the equation true. So to find the solution of such an equation, choose any value for x, and again I say any, okay, because it's any number. Substitute that value into the equation and find the corresponding value for y. Okay, how do you do this? Let's take a look at example number 1. Find 4 solutions in the equation y equals negative 2x plus 1. Okay, and then write the solutions as ordered pairs. And letter B, graph the equation of y equals negative 2x plus 1. So let's look at letter A. Okay, so we want to choose 4 convenient values for x. Convenient meaning it's easy to solve. Okay, substitute each value for x in the expression negative 2x plus 1. Okay, and then in this case we chose the values for x as negative 2, 0, 1, and 3. You can use any values, but these are the 4 convenient values. Okay, after choosing 4 convenient values, do the computation to find y, and since y equals negative 2x plus 1, we simply write negative 2x plus 1 in the middle part of our table. Okay, and from there we substitute negative 2 to x, so we end up with negative 2 times negative 2 plus 1, okay, which has a value of y of 5, because negative 2 times negative 2 is positive 4 plus 1 is 5. If we substitute 0 to x, the value of y would be 1. Substitute 1 to x, the value of y would be negative 1. And if we substitute 3 to x, the value of y would be 5. Okay? And then do the computation to find y. We did that. And finally, the 4 solutions are negative 2, 5, 0, 1, 1, and negative 1, and 3, negative 5. And it says in letter B, graph the equation y equals negative 2x plus 1. Okay, so first graph the ordered pairs you found in part A, okay, which is this one. So we graphed all these 4 points. And then after graphing all these 4 points, we simply connected the points and made a line out of it. Okay, so draw a line that contains these points, and that's how you graph the equation y equals negative 2x plus 1. Okay? The ordered pair for every point on the line in example in part B, when we graphed it, of example 1 is a solution of y equals negative 2x plus 1. Okay? It appears in the graph that negative 1.54 and 2, negative 3 are also solutions. You can check this substitution. Basically, what is it saying? It's saying this. Let me go back there. And let me go back to our graphs. Okay? So this is the graph of the equation negative 2x. Okay, so this is the graph. That line right there is the graph of y equals negative 2x plus 1. What it's saying is this. Okay, so you have that straight line. Every single point, okay, that is on that line will make this equation true. So every single point that lies on that line will make this equation true, and that's what it's saying here. Okay, the ordered pair for every point on the line in part B of example 1 is a solution of y equals negative 2x plus 1. And if you look at negative 1.5 and 4 and 2, negative 3, they lie on the line. And if we check this by substitution, okay, negative 1.5 and 4, so we substitute negative 1.5 to x and 4 to y. So 4, is it equal to negative 2 times negative 1.5 plus 1? Yes, it is. And we check the other point, 2, negative 3. Okay, we find out that it is also equal. Okay, so in this case, an equation like y equals negative 2x plus 1 is called a linear equation because its graph is a straight line. And that's why we call it a linear equation, because it creates a straight line. An equation with two variables is an infinite number of solutions. So in this case, okay, a linear equation will have an infinite number of solutions. Okay, let's take a look at example number 2. Oh, my tablet is running down. Okay, let's just finish this recording. In any right triangle, the sum of the measures of two acute angles is 90 degrees. Okay, if x and y represent the measures of two acute angles, then the equation x plus y equals 90 models this condition. Okay, so remember what an acute angle is. An acute angle is an angle wherein two angles of the triangle measure less than 90 degrees. Okay, if x and y represent the measures of the two acute angles, okay, then the equation x plus y equals 90, because you already have a right angle which measures 90 degrees. And if you remember, the sum of the angles in a triangle equals 180 degrees. So if this is 90, then the sum of x and y should also equal 90 to be able to be equal to 180 degrees. Remember, in the triangle, okay, the sum of the angles should measure 180 degrees. So let's graph the equation, letter A, okay, and use the graph to name another solution for the equation. And letter C is negative 10 over 100, a solution of the equation. So let's look at letter A, okay, and let's graph the equation. Before we do that, okay, we need to solve the equation for y in terms of x. What does that mean? It simply means that with the equation x plus y equals 90, we need to solve for y, or we need to isolate y on one side of the equation so that it's easier for us to make a table. So let's start with the original equation x plus y equals 90, and we need to isolate y. That's what it means when it says solve the equation for y in terms of x. Okay, so that means we are solving for y and putting x on the right side of the equation. So how do we do this? We subtract x to both sides. Okay, if you subtract x both sides, you end up with y equals 90 minus x. Now that we have the solved y in terms of x, we can now make ordered pairs that satisfy the equations. Since any line can be defined by only 2 points, only 2 ordered pairs are needed. Finding a third ordered pair is a good idea to check the accuracy of the first two. So what it's saying is you choose 3 points, even though 2 points can make a straight line. The third point is just to verify that the line is straight. Okay, so we have, since y equals 90 minus x, we put 90 minus x there. Okay, and we choose any 3 values of y. Okay, doesn't matter which, we'll choose 45 first, and if we substitute 45 to x, our y will be 45, our ordered pair would be 45 and 45. Another one will be 10. Substitute x to 10 to x, that would be 90 minus 10, our y would be 80. Our ordered pair will be 10 and 80, and the last ordered, we can try 70 and substitute 70 to x. That would be 90 minus 70, our y would be 20, our ordered pair would be 70 and 20. Okay, then after finding our table, we can now graph our table. Okay, graph our line, graph the ordered pairs and connect the line. Okay, so we have 45, 45 right here. Okay, 10 and 80 right there, 7 and 20, and we connect all those points. That is the graph of that equation. Okay, and letter B, it's asking, use the graph to name another solution to the ordered pair. We simply want to look for another point. This point will work right over here. This point will work right over here. Any point on the line would work. Okay, so the point that we chose is 50 and 40, which is this one right here. 50 and 40 right there. Okay, and it's on the graph. Since 50, 40 is on the graph, it is another solution to the equation. Okay, and letter C, it's asking, is negative 10, 100, negative 10 and 100 a solution to the equation? Is the ordered pair a solution to the equation? So we substitute the value of x and y. Negative 10 plus 100 equals 90. Since you have negative 10 as your x and y as your 100, so this is your x and that is your y, and we substitute that. That's why we have negative 10 plus 100 equals 90. Okay, the ordered pair is a solution of the equation. Okay, however, since angles in the triangles cannot have negative measure, the domain for this particular situation should not include negative numbers, and that's the reason why we have we're only graphing this in quadrant 1. Okay, there are no such thing as a negative measure in a triangle. Okay, and a good question that will come up is, should the domain be equal to 0? Again, okay, if your domain, or if you let x be equal to 0, this would not make sense. Okay, because if x were equal to 0, okay, then you would not form a triangle. Okay, to be able to form a triangle, you need to form 3 angles, and if one of the angles is 0 degrees, okay, it's not a triangle. Okay, so that answers that question. And the secret word for this particular lesson would be breeze. The secret word is breeze. Okay, thank you for watching.